Okay, what are we talking about right now? Logarithms. Why do we have to have logarithms? Why do we have to know how to do them? They are important. Why? What? State says so. Why else? We wrote it on the back of our Intro to Logs worksheet the other day. They are the inverse functions of exponentials. Good. So that should help you remember why we have to have them. Okay. Why do we have to know how to do logarithms? What happens when we're trying to solve an equation and the variable is in the exponent? Logarithms help us get it out. Okay, so we've covered basics so far, like how to go back and forth from exponential to logarithmic. We've talked about some of the specific rules where the bases are the same, the answer is what's left, things like that. So today we're going to do your favorite thing, transformations. Okay, so the assignment that I gave you for today is kind of a mix between logarithms and exponents. And why would I do that again, Maddie? Because they're what? They're inverses of each other, right? So they're really closely related. So I put them together so that you would keep that in your head. Okay? So just as a reminder, the first couple examples I'm going to show you are not logarithms. They are in exponential equations. Tell me how that moves compared to its parent. I mean, please tell me how that moves compared to its parent. What you got? So what is the 2? The 2 is the base, so that's the parent. So what does that do? Horizontal shift left 5. Yeah? What about that one? It is. Why? The negative in front, the negative multiplier in the front, that is a reflection. It reflects over the x-axis, absolutely. So vertical shift. Up 4, absolutely. Any questions? Okay. Do I need to do any more exponential or you got that okay? All right. What's the hardest part always when we start a transformation section? Figuring out what? What's horizontal and vertical, because we need to know what's inside and what's outside. What does it mean to be inside a logarithm? What does it mean to be outside a logarithm, right? Okay. So I want to make something clear. Is that apparent? Yes. Is that apparent? Yes. Is that apparent? Yes, right? That's log base e, but we don't write it that way. We always write natural log. So these are all parents. So similar to exponents where you can have multiple parents, you can also have multiple parents with logarithms, okay? So here we go. Y equals negative log base 2 of x plus 5 versus y equals negative log base 2 of x plus 5. Do you see the difference, first of all? Yes, okay. They both have a reflection. If you have an issue with the fact that sometimes I write reflex over x-axis and sometimes I write reflection over x-axis, I just need you to get over that right now. Because sometimes I write it one way, and it's not different, is it? The words are different, obviously. The meaning is the same, yes? If it bothers you, I have tissues by the door in case you cry. Okay. So tell me the difference in these two. So one has parentheses and one doesn't. So one has an inside and one has an outside, right? Which one's which? Parentheses is inside. This is inside the logarithm. If it's inside the logarithm, what kind of change is that? That's a horizontal change. What kind of change? It is a shift left 5. Done. So if it's outside, and you can tell it's outside because there's no parentheses, then it's a vertical change, in this case a shift. And what is the most important part? The F, right? Don't forget your F's. Vertical shift, God bless you, up 5. Yeah? Do you need a whole bunch more examples? Because at least has been apparent in the last couple times we've done transformations, once you've figured out where's inside and outside, you got the rest of it. Because why? The rules are the same, right? The rules are the same because of transformations. Figuring out inside and outside is the quote-unquote hardest part, even though it's not hard, is it? Okay? Any questions?